All right. Well, good Friday morning, everyone. Welcome to October. For those of you that care, we're only about 11 weeks away from the winter solstice when the days start getting longer again, for those of you to whom that matters. And welcome to the 4th episode of the 2nd season of the Backyard Naturalist series, where we look at the extraordinary stories among the ordinary critters in your backyard. And today's episode is called the Good Leopard Slug. And I decided to do this episode after a couple people, some colleagues and some people in the community recently took photos of slugs they found in their yards looking for identification help. And since they obviously didn't have their iNaturalist apps at the ready, and in all the cases, the photos were of leopard slugs. And that was the impetus to do an episode on the leopard slugs since they were starting to show up in people's backyards. And as usually the case, after doing the research, the slug stories did not disappoint me, and hopefully they won't disappoint you either. So thanks again for spending part of your Friday morning with me, or if you're watching this recorded, whatever the day or time, I'm happy to be spending it with you. But first, the Backyard Naturalist series is brought to you by the UEC In My Backyard, which just received the first part of a 2-part makeover. So you'll see the website is now grouped slightly differently. There's a section for kids where you'll find features like Story with Tori. There's a section for adults where you'll find these lectures plus blogs and other stories and videos. And then there's a section for everyone where you'll find features like 5 Facts with Danny. Their latest video is 5 Facts about the Eastern Chipmunk. And what are those 5 facts? To find out, visit the UEC In My Backyard website. Your homework for this week is to read Maggie Steinhauer's recent poetic description about the ephemerality of dragonflies in her latest blog, and some of the ways that they adapt to the coming winter cold, apart from cursing the season of autumn like some of my human friends. So please visit the UEC In My Backyard website. And this weekend marks the end of the week-long revamp of Hike Milwaukee. There have been some fantastic hikes led by staff volunteers and community partners all week, and there's still room for you to sign up for a solo guided hike or one of the small group hikes where masks and distancing is required, but learning and enjoyment see no bounds. To see what hikes still have space, visit the Urban Ecology Center website. And I am shamelessly and happily accepting donations from my personal fundraising page for Hike Milwaukee, which is the annual fundraiser for the Urban Ecology Center. Unlike the PBS calls that come probably every quarter, these come once a year. And I'm currently, I think, $100 away from my fundraising goal. And every donation through tomorrow is matched by a friend of the center. So if you'd like to contribute, you can visit my Facebook page or email me and I'll send you a link. Let's see if this works. Okay. So today's featured backyard critter is the leopard slug. And of course, there's a lot to say about slugs in general. And we'll start by figuring out what the heck a slug is. We've now featured about 25 different species or groups of species in the Backyard Naturalist series. And the leopard slug represents the very first mollusk. So we'll back up the question just a bit and first ask what a mollusk is. Mollusks are a diverse phylum of invertebrate animals, meaning they don't have a backbone or an internal skeleton. There are about 85,000 extant or living species of mollusks that have been classified, and still many, many more that we have yet to discover or classify. They make up about 25% of all marine life, but also live in freshwater and terrestrial habitats. They include the neurologically advanced cephalopods, which include squid and octopuses, one of my favorite organisms of all time. Super smart. They include clams, mussels, and other organisms pictured here, many of them yummy, and of course the gastropods, which are the snails and slugs and a few of their friends. Mollusks share the characteristic of having a mantle around a body cavity behind the head, which serves most of the important body functions like eating and pooping. And in many cases, the mantle is surrounded by and protected by a shell, as is in the case of an oyster or a snail, or sometimes 2 shells, as in the case of clams or mussels. And sometimes the mantle is soft, as is the case in octopuses, sometimes just protected by a tiny shield or nothing at all. So you can imagine that the octopus mantle at one point evolutionarily was protected by a shell, as is the case with the related Nautilus. But the octopuses eventually lost that protective shell. And once again, octopuses is the correct form for plural octopus. And even though some octopuses still have a tiny remnant shell sticking around there inside the mantle, thankfully for us, it's tiny or absent. Otherwise, we wouldn't be able to watch all those fun octopus videos where they squeeze through tiny holes or hang out in bottles. And the mantle of slugs lies behind the head, and as you can see in the lower right. And again, that area performs a lot of the important bodily functions of the slug, like breathing, pooping, and even mating, while most of the slug is just that one big giant muscular foot. So everything that was kind of tucked up in that shell is now under that mantle, and that kind of saddle-like structure that's still there sort of protecting that area. Most mollusks have these cool radula, which is the structural equivalent of a tongue. And in many cases, the radula can be heavily armed with sharp tooth-like structures, especially in predatory mollusks, but they're even found in the mollusks that are scraping the vegetation in your aquarium. So if you thought snails were cute and cuddly, these upper two photos are of snails. And they surely must have helped inspire some of the monsters that we portray in movies and books. But there's some pretty scary things when you think about getting sucked into the mouth of some of these mollusks and what lies inside. Some have described them as these teeth that just will let you get in but won't let you get out, like those barriers in the bottom of parking lots that let you go in one way but don't let you back out. So the ancestral mollusk likely looked like limpets, which are alive today. You'll see them attached to rocks like barnacles at low tide. And then once the tide comes in, they move around to feed, and then they come back. So it's likely that the ancestral mollusk had this hard protective shell on top covering that soft muscular foot. And in case you couldn't hear it when I said foot, there were quotes on either side of the word because it's really a foot-like structure. I really do wish limpets lived in our backyard so I could feature them in this series because they are one of the coolest creatures out there. In grad school, I did a small study on limpets in tidal pools off the Nicoya Peninsula in Costa Rica, and I marked individual limpets and the positions on the rocks that they took during low tide. And then in subsequent low tides, I looked to see if they came back to the exact same spots. And for the most part, they did, but every once in a while, it looked like there might have been some jostling for position. And so some of them were slightly off or in different places, kind of like when you're on a tour bus and people tend to want the same seats they started with. So every time you get off the bus and get back on the bus, they go back to those same seats as if they're entitled to them. And then there's that jerk who talks too much and takes your seat, and then you have to move to a different part of the bus but you make sure that he sees your stink eye of disapproval first. So you know what I'm talking about here. Mollusks represent a significant protein source for humans, and some of my favorite foods are mollusks, which often conveniently come in their own serving dishes. I kind of want to say that I like snails, but I've never really gotten into them. I just think of them as the things that sop up the garlic and the butter and just give it enough structure so that you can chew it rather than drink it. But mollusks also give us pearls, and their shells have been used as currency by past human cultures. So they continue to be and have been for a long time important to humanity, but they also represent a bit of a risk to humanity. The blue-ringed octopus and the cone shell are some of the most venomous creatures on Earth. When I was in Australia, a beachgoer had picked up a cone shell and put it in his pocket. And then a few hours later, he literally dropped dead. And no one knew why at first. They thought it was a heart attack. But what ended up getting him was that he had found a cone shell, stuck it in his pocket. And then a few hours later, the cone shell stung him through his pants and ended up killing him. And again, it took a while for the folks to figure out what the cause of death was. So some of the most dangerous critters on Earth are mollusks. And Schistosomiasis is a disease spread by freshwater snails using flatworms as they're the vector for the flatworms, and that can kill up to 200,000 people globally each year. So they can be very dangerous to humans, and many snails and slugs, like with Rosemary's Garden, as we can see, we'll see that they're invasive, and they can be serious agricultural pests. Final thought about mollusks before we move on is that they've made a huge contribution to the field of paleontology because those hard calcium carbonate mantle shells preserve very well. And so many of the fossils that we find are the shells of brachiopods and gastropods and cephalopods. And particularly because we find them in such great numbers, it really allows for good analyses of the past, as opposed to dinosaurs, which are also important, but we may only have a handful of specimens of a given species, whereas with mollusks, we can have thousands and thousands or hundreds and thousands of species to work with. So after this talk, you can go to Hubbard Lodge and search along the riverbank, kind of underneath the boardwalk. And it's a great place to look for fossils. You can find fossil brachiopods from the Silurian seas that covered Milwaukee hundreds of millions of years ago. And of course, the mollusks without shells, like the slugs, don't really preserve at all. So they're unfortunately pretty much absent from the fossil record. Snails and slugs, along with limpets and a few other groups, belong to the Gastropod class. Gastropod, even though they are yummy, doesn't mean yummy. It means belly-footed, or it's loosely translated as foot on stomach. So there are about 80,000 named species of gastropods, making them second only to insects in overall numbers. And the study of this group is called malacology. So if you want to be a malacologist, you can study snails and shells and the like. This originates from the Greek malakos, which means soft-bodied. So despite all of these hard shells we find in this group, the study of them focuses on their soft, squishy bodies. So big question number one. What is the difference between a snail and a slug? If you look at the evolutionary tree of all the gastropods, there are slugs and snails in a lot of different groups. So the term slug isn't an evolutionary grouping, but it's a grouping based on the physical characteristics of losing its shell, and that crosses several groups. So snails don't belong to a specific evolutionary group, and slugs don't belong to a specific group. But along each of these groups, you find snails and slugs, and snails are the ones that kept their shell through time, and slugs are the ones that lost them. Some slugs, so with that, some slugs are more closely related to snails than they are to other slugs, and vice versa. So it's the same if you look at a group of plants, like a specific family of plants. Within that plant family, they can have trees and shrubs and vines, which is kind of the equivalent of the snail versus the slug. But in the case of gastropods, the grouping, it's really independent. So whether each group lost its shell has to do with the physical characteristics of the time and the things that they've had to adapt to. So with this in mind, there are actually three major groupings. So first we have snails, and a mollusk is considered a snail if it can completely retract its body inside the shell. And then second, a mollusk is considered a slug if it no longer has that shell. And then the really cool thing about slugs, next time you see one, is that you can still see the mantle, which is that smooth area by the head. But instead of being out in that shell, all of that stuff is now tucked in its body. And that mantle is just kind of, you can see where it's all packed. And for some, that mantle does have a little bit of protection, but it's mainly a remnant of where the shell was. And then there's a third category, which is my favorite, called semi-slugs, which still have a shell, but it's too small for the snail to completely retract inside of it. So in this picture, you can really see that evolutionary halfway point of losing a shell. But slugs didn't really lose their shell. A more accurate description would be that the shells kind of got swallowed up internally to become a remnant shell or a shell of a shell. So if you just think of a slug as this long blob, when you really look into it, that upper dorsal saddle area is really where most of the important bodily functions are still happening. And the rest of it is really just a big muscle of a foot. And so you can see some really interesting patterns along that mantle area. Some semi-slugs are further along in the process. And like octopuses, they still retain a little bit of that internal shell, which becomes more of a smaller and smaller disc that you can often still see because the skin itself can be semi-translucent. But, you know, again, if you're thinking of that the only difference between snails and slugs is the presence of the shell, you were right. It really is that simple, with the semi-slugs thrown in for a little flavor. And because of the evolutionary pathway of this group, it's more accurate to say that slugs are snails that lost their shell rather than the opposite, snails being slugs that gained a shell, if you follow me. The purpose of the shell is twofold, at least twofold. Most of us probably associate the shell with defense against predators, and that is accurate, especially for marine snails. But for land snails, that shell has the additional extremely important benefit of providing protection against drying out in the air. According to Dr. Jan Vendetti at the National History Museum of Los Angeles, as mentioned in my favorite podcast, Ologies with Allie Ward, she is not exaggerating by saying that one of the biggest evolutionary innovations in the history of life was the transition by gastropods and amphibians from a marine environment to both terrestrial and freshwater environments. Because you can imagine that living in a salt water for a soft-bodied organism that has some pretty extreme demands, you're getting your oxygen from the water that is very salty, you're getting it through your skin, and then now you're taking that body form and moving it onto land where you now need to get your oxygen from the air. And you need to figure out a way to keep your skin from drying out, which, you know, the amphibians also face. So that defensive shell for the snails became a great way to help keep that moisture inside when needed. And for many snails, if they find themselves in a dry spell or adverse conditions, they'll curl up tight in that shell, and they can stay there for weeks or even months in a kind of suspended hibernation until conditions improve. So for the land snails, that shell is really important to keep them from drying out. But if you're a slug, you don't have that option. And maybe they start thinking, oh, maybe losing that shell wasn't such a good idea after all. So slugs gain some freedom from losing the shell, but they're for sure more limited in where they can go. And so more so than snails, they really need to stay in areas with high humidity, just like amphibians do. So whether that means coastal areas or tropical areas, or for more inland temperate slugs, and we don't have a lot of native slugs here in Wisconsin, it means hanging out in damp areas, you know, under logs or in shaded vegetation, or, you know, your lawns or your gardens, wherever you probably normally find them. And then this slide also shows that they rely on their really cute, inquisitive faces, which must have been the inspiration for several of Jim Henson's Muppets or Guillermo del Toro creatures. And while you're looking at these adorable faces, it's also a good time to point out that you may have noticed that there's 4 stalks coming out of the head. And essentially the upper set of tentacles are the eye stalks that can form, they think, rudimentary optical images. And for many snails and slugs, they can not only pull those stalks into their head, they can pull the eye parts into the stalk. And then the lower set of tentacles serves more of an olfactory function, or a sense of smell, sensing chemicals and pheromones in the air. But probably the biggest adaptation for dealing with a terrestrial environment that those folks we were talking to before the talk had mentioned is slime. And I think most of us think of slime when we think of snail or slugs. And thanks to Maggie, I'm now going to not call those slime trails anymore. I'm going to call them glitter trails. That's a much more, it's a much better way of looking at it. But snail and slug slime is, to many people, pretty disgusting and the characteristic of this group. And that's probably a good way to look at it because the slime itself does carry and spread diseases. And as you'll see today, most of this lecture is about the slime, and because it is the biggest characteristic of this group. And so a look into slime is way more than meets the eye or your fingers. So slime isn't just slime. There are many different types of slimes that serve different roles, and it's really complex. So first, as seen here, you see the slime or glitter trail, which is mostly slippery. And slippery slime functions like ball bearings, which allows the animal to move easily along a rough substrate. It reduces friction. And when I look at that, my first question is, well, where does the slug get all that water, particularly if it's trying to keep itself from drying out and it's leaving this huge trail of water behind it? So it seems like it would dry out pretty fast. But it turns out that a major component of slime is something called hyaluronic acid, which now people are really starting to tap into slimes as a beauty feature to keep your skin soft and moist. And really, it probably does do that well, but it's really doesn't do it any better than a lot of the other products out there. But it's just that, cool factor of they'll come up with some snail that has some pretty exotic name, even though it's probably the scientific name, or the real name is like the common European snail or something like that, or the slug. But they'll take that and then it adds the bit of mystique to the product, and people will pay more money for it. But it does have a very interesting characteristic of moisture retention. And chemicals like hyaluronic acid, which is a sugar, can essentially hold and absorb up to 1,000 times its weight in water. So from hundreds to up to 1,000 times of its weight in water is the characteristic of slime. So snail slime is almost entirely water, but it has some complex binding chemicals in there. And so a quick recharge will supply enough water for a pretty long trip, kind of like a camel can drink water and then go for a long time. But it's more than that. The property of slime, it's characterized as a crystal liquid. And so it allows the slime actually absorbs more water from the surrounding area as it's moving forward. So even as it's losing water to that slime trail, it's also like sucking up all the water that it's in the environment, which is pretty crazy to think about. So slime isn't just slime. It's really complex. You probably shouldn't touch it because, again, they are vectors of diseases, but it's pretty crazy to think of it next time you see one. The second major type of slime is a sticky slime, which, as you can imagine, allows the animal to climb slippery surfaces. If it just had that slippery slime, there's no way a slug would be able to climb anything. But with that right combination of sticky and slippery and that crystal liquid property, they perfected climbing vegetation and other substrates, including, pure glass. And a quick side note is that scientists really are studying the chemical of slime for many, many applications, including that sticky part is being looked at as a surgical glue. So slugs really do have a lot to add to humanity. The third major type of slime is a defensive slime. So really noxious, poisonous chemicals that are used in defense. And this is particularly important for slugs because, again, they've lost that protection of their shells. Banana slugs in particular are known for their toxins. And while not all toxic slugs are brightly colored, it's likely that in this case, that bright yellow color is an epistematic warning to predators, a common pattern we see in wildlife for very venomous or very poisonous creatures, saying, I want you to see me because if you try to eat me, it's going to be a lose-lose situation. So even, oh, go ahead.
We have a quick question. Are leeches a type of slug?
I don't believe so, no. I think leeches are an entirely different group. It's an excellent question, but no, leeches are not in the slug. Leeches are not mollusks. Good question. We'll talk about leeches. That'll be we got amoeba last time. I know people want to know more about amoeba, and we got leeches. So, although leeches don't really, well, anyway. So, even though we still have a lot more to talk about with slime, I think this is probably a good time to pause, and we'll watch a short PBS video that kind of looks a little closer at the slime functions and does a little bit better job explaining it than I can. So let's watch together.
Beneath the towering redwoods lives one of the most peculiar creatures in California, the banana slug. And what makes a banana slug so peculiarly slug-like is its glorious slime. They're covered in it, but why? Slime is a brilliant solution to many problems that slugs face in the forest. Slugs are mostly water, which means they deal constantly with the threat of dehydration. And you'd think that laying down that thick layer of slime would be hard to maintain and use up a bunch of water. But slime actually attracts water. It's produced by cells in the slug's skin called goblet cells. Tiny granules of mucus emerge from the cells, then pop open and absorb water from the surroundings. One mucus granule can absorb 100 times its own volume in water. Slime is also critical to how a slug moves. Slugs drag themselves across the forest floor with rhythmic waves of muscular contractions.
You can see the mantle on that.
But the forest floor is rough terrain. Slime is a great lubricant. It lets the slug glide over dirt and leaves. Slime also helps slugs find each other over huge distances, at least huge slug distances. Chemicals in slime trails tell slugs which direction another slug was headed, maybe leading it to a potential mate. Oh, and slime is recyclable. Slugs eat other slugs' slime, like a little snack they find en route. They even eat their own slime sometimes. So what is slime? Well, you've got your liquids. That's where molecules float randomly all over the place. And you've got your solids, where molecules are packed closely together, fixed in place. A liquid crystal, that's what slime is in between those two things. The molecules are aligned with their neighbors, but they can move and flow together. This structure gives slime a strange ability to be either a lubricant or an adhesive, slick or sticky, allowing a slug to adhere to almost any surface or glide with ease. Chemically, slime is very similar to human mucus, which is also a liquid crystal. Your body produces about 6 cups of mucus a day, even more than that if you've got a cold. But instead of using it on the outside of your body, like slugs do, you use it inside. The gluiness traps bacteria and pollen that enter through your nose, keeps it from irritating your lungs or getting into your bloodstream, where it could make you sick. It also protects the insides of your digestive system. Engineers would love to figure out how to synthesize this stuff to make use of its incredible properties. Remember when we said slime can absorb water? Well, here's a design for a greenhouse window inspired by slug skin that can store and release humidity. And here's a robot that mimics the way slugs use slime and muscular waves to climb walls and ceilings. These are just a couple ways the world could get a bit slimier in the future. All inspired by the humble banana slug, our partner in slime.
So that is a fantastic video, and I'll be sure to share the link with you all in the email. And the other thing I'm jealous about with these videos is they can put all these great soundtracks in it. If you go to Maggie's blog about dragonflies and click on the video in there, there's a really fantastic look at a dragonfly swarm set to kind of like a Keystone Cops type of soundtrack. But anyway, we'll move on here. Let me just, okay. So, one second here. All right, so back to slime. I think maybe the most fun By the way, it's really hard to say slime with all these other words, slug, slime, and I feel like there's a lot of S's and L's and there's a lot of tongue twisting going on here today. But the most fun function of slug and snail slime to me has to do with mating. So slug density or snail density can be pretty low in some cases. And so finding another slug for mating could be pretty difficult. But by leaving a trail of slime that's laden with hormones and pheromones among everything else, as is mentioned in the video, a slug can tell another slug, hey, here's where I've been and here's where I'm going. So if you want to come find me, you can. And for some reason, this can be particularly effective after a light rain, which somewhat goes against common sense because you think it would dilute those trails, but apparently there's some kind of amplification of the pheromones with a light rain. So the trail of slime helps slugs find each other for mating. But then you might wonder on the flip side of that coin that a slime trail would also allow predators to find you. And while that is the case, slugs will often leave these really defensive toxins that they usually have in their body in their slime. And so if a predator picks up on those toxins in the slime trail, that's usually enough to say, nope, that's all right. I don't need to find that meal today. After you get past the different types and the complexities of slime, oh, and another side note, you can identify species by their slime trail alone. So just a little genetic analysis of that slime trail, you can identify 2 species. But when researching gastropods, the first thing you come to after slime is inevitably slug mating systems. They are as diverse as they are bizarre and complex and crazy. And again, as is the case with the slime, I could never do justice explaining slug mating systems, particularly in this format, without a lot of giggling. And combined with the fact that maybe the best video in history has already been made on this topic by one of my personal heroes, David Attenborough, we're going to get a little twofer in the videos today. But before we watch his video, there are a few things I should mention related to slug mating. First of all, almost all slugs are hermaphroditic, which means individuals have both male and female parts. Sometimes they can mate with themselves, and sometimes that is a strategy, but for the most part, in almost every organism, it's not. So you're not producing clones of yourself, you're producing new yous with just slightly different combinations. So it's a little weird to think about, and it's a very, very, very narrow strategy and rarely used and only in certain circumstances. So most hermaphrodites don't mate with themselves. And again, that's different from cloning yourself. But hermaphrodites probably represent, if you think about it, the most egalitarian and efficient mating system, because when 2 individuals meet and mate, they both impregnate each other. And then the other really crazy thing about slugs has to do with their male organs, and they're pretty incredible, as you'll see in this video, and they can be really big. Their penises sprout from the mantle area just behind the head. Again, that mantle area is where most of the bodily functions happen, and it can be as long as the entire body. In fact, the scientific name for the banana slug translates to big penis. So with this background in mind, we'll enjoy this masterpiece. It is all David Attenborough's videos, but particularly this one. I have to thank Corey for sharing this one with me.
So all these animals, having left the sea, solved the problems of moving around and breathing air in their own differing ways. But there was another difficulty: mating. In the sea, animals need only release their eggs and sperm, and the water mix the 2 together. On dry land, that couldn't happen, even for the most moisture-loving of creatures. An individual slug carries both male and female organs, but even then, that was of no help. Each had to both give and receive. Somehow or other, pairs of individuals had to get together, and the ways they have evolved in which to do so are quite extraordinary indeed. Some of them are almost beyond imagining. The leopard slug, you might think, has the simplest of habits. Maybe, but not when it comes to mating. When an individual is looking for a partner, it gives its trail of slime a special taste that advertises the fact. Another, if it feels the same way, will detect the invitation and start to follow. The pursuer, to confirm that it's there and ready to mate, gives the pursued a nibble. The leader heads upwards. An overhang is what's needed. The underside of a branch will do very nicely. The two start to circle one another more and more closely until they entwine. For an hour or so, they continue to wind themselves around one another. Then, suddenly, the pair release their hold on the branch and start to slide downwards on a rope of mucus. Now, in mid-air, they move to the next stage in their pairing. Each everts its male organ from just behind its head. These grow longer and longer. Then they too begin to entwine. They fan out to form a translucent, flower-like globe. And now, at last, sperm passes from one slug to the other. The transfer is complete. Each has been fertilized. Finally, their strange balletic relationship comes to an end.
So tell me, you look at me in the eye and tell me you can now look at your garden slug in the same way after seeing that video. That's pretty incredible. I did hear from some colleagues at work that David Attenborough is coming out with kind of his final swan song documentary soon. That's essentially going to be his final plea to humanity to stop screwing up the world. And just the thought of David Attenborough retiring is almost too much for me to take. So when folks like Danny and Maggie and I are going to be watching that, I doubt it's going to be hard for us to watch through all the tears that are probably going to be streaming down our face. That man is just something else. All right, I'm going to move on now to kind of an important public service announcement, and hopefully something like this has never entered your mind. But don't ever eat a raw slug or snail or lick them, or if you handle them, please wash your hands. They're not venomous, but in addition to all those nasty poisons they excrete in their slime, they are a pretty common vector of diseases, as we mentioned earlier. They carry organisms that cause things like rat lungworm. And if you don't know what rat lungworm is, you probably want to keep it that way. As much as I encourage curiosity with nature, I think it's okay to go out your entire life without knowing about rat lungworm. But they also carry things like meningitis and schistosomiasis, as I mentioned before. And um, there aren't a whole lot of native snails and slugs in Wisconsin. So most of the ones that we find, including the leopard slug, were brought here either intentionally as pets or in aquaria, or often in produce that's shipped around the world, which is another reminder to really wash those leafy greens, because that is one of the ways they transmit diseases, through their slime and into your lettuce or spinach. And even if it's locally grown organic lettuce or produce, slugs and snails have become pretty common foreign invaders on our land, just like worms. Which brings us to our next kind of discussion question here. Are slugs good for your garden or your backyard? And I kind of look at this in two different ways. So slugs and snails as a group in their native habitat do play an important ecological role, like the banana slugs, which are native to places like the northwestern part of the US and are important grazers and decomposers and are food for animals. The raccoon in particular has found a good way to get around the banana slug's toxins. They actually will roll them in mud, and then the mud kind of starts to neutralize what's in the slime, kind of like clay does. And then once it's rolled in the mud, the raccoon can just go ahead and chow down like it's eating a gummy worm. In fact, I encourage you to search the videos of raccoons eating slugs. They're pretty funny. And there's one video where that shows right before the raccoon eats it, shows a garter snake trying to eat one, but just failing miserably because of the slime and the properties, and it ends up, throwing up the slug, which is no worse for the wearer because they are squishy, and then the snake kind of limps away with a really bad taste in its mouth. But they are, if they're in your garden or your yard, and I hope I'm not bursting anyone's bubble, but really in the city, it's almost all of the slugs and snails you find are not native. The common city slugs and snails, I think it's called the common European snail, sometimes known as the wet sidewalk snail, or leopard snails. Almost everything that you find are introduced, either intentionally or accidentally, and most of them are growing in areas of little or no predation. So they can cause some problems to the communities of wildlife, in addition to eating your garden plants or potentially spreading diseases. Unlike worms, which are also invasive, they don't aerate your soil. There may be some narrow ecological benefit to slugs, but it's likely that the damage they cause is worse than those benefits, particularly when you're talking about outcompeting native species. And interestingly, the presence of worms, which again are also exotic invaders, they can help neutralize the spread of slugs, likely because they occupy very similar niches, and they kind of compete with each other. So one group kind of prevents the other group from getting too big. So even though the leopard slug was our cover critter for this episode, the main thing that distinguishes the leopard slug is that crazy mating system that we saw. And apart from that, they do have a pretty cool scientific name, Limax maximus, which translates as biggest slug. And you can see here why they're called the leopard slug. Although they don't always show these spots very clearly, they can grow up to about 8 inches long. They're native to Europe, and in Wisconsin, unfortunately, they are a problem invasive species. If they're attacked, they will kind of expand that mantle, which is a little bit like a shield, and kind of attempt to draw the head under. So kind of like how a snapping turtle can't go in its shell, but it can kind of hide underneath it a little bit. And so it does have some protective function. And for the most part, they're active at night. And just like the limpet that kind of finds a nice place to stay during the day and then goes out and then comes back, the slug does something very similar. And it once it finds a place to hang out during the day, it'll go back to that place over and over again. And then at night it goes out in foraging bouts. They can eat other slugs, pursuing them at cheetah-like speeds of 6 inches per minute. And It also eats crops. It's a major agricultural pest in the US, particularly in the South and the West. They do clean up dead plants and fungi as detritivores. And like most, I'd say a lot of the slugs, particularly outside of their native range, and snails, are mostly found near human habitation because we provide them with a rich environment of food and dark, moist microhabitats like lawns and gardens and sheds and cellars. And so your word for today describes the leopard slug and almost every creature featured in this series, and that word is synanthropy. A synanthropic organism is one that benefits from human environments. So like lawns and parks and neighborhoods and buildings, basements. Synanthropic organisms live near and with humans because of the changes that humans have made to the landscape. So they're often generalists and include, again, the coyotes and possums and squirrels and roly-polies and plants that we've featured throughout this series. And if you're wondering what the end result of that elaborate ballet of a mating system that we looked at, here it is. They find a nice, dark, wet environment to deposit a cluster of fertilized eggs that then turn into tiny, cute leopard slugs that then grow into bigger leopard slugs that then eat and make more leopard slugs. So slugs are fascinating creatures. Maybe you'll have a different outlook when you see one in your yard. You can do your part to help prevent the spread of harmful slugs and snails by being careful about what you bring home as a pet or what you put in your aquarium. And apart from that, maybe helping to spread the word to friends and restaurant owners that may inadvertently release escargot into the environment. I remember one year when we were banding in Lincoln Park, and maybe it's still like this, but the plants along the river were just teeming with these large land snails, and we found out that they're the kind that are eaten in restaurants and likely escaped from or released from a restaurant, and they became very successful feral population, at least for that season. It's slightly, snails and slugs are slightly less of a problem in the north where cold winters can kill some of them, but there are some that are very successful here, and there's probably not a whole lot more we can do other than enjoy them. Unlike worms, there are a few native slugs and snails, and one group of native slug has a mantle that extends almost the entire length of its body. But I was really hard pressed to find much more information on native slugs and if any of them are protected. So my guess is that there hasn't been much slug studying happening here, since we're not really a hotbed of native slug diversity. But maybe some of you can help me find some resources on this. But I will say that slugs are amazing creatures to be enjoyed, preferably at a distance, preferably in their native habitat. But in my yard or in the parks, when I do see them, I enjoy them because of their evolutionary success. And then you can kind of take a closer look at their anatomy and just see how they've adapted to life in amazing ways.